Right, Assalamualaikum, selamat pagi.
Waalaikumsalam.
Waalaikumsalam, sir.
Okay,
Waalaikumsalam, sir.
kita sambung chapter sikit and then I'm going to leave you. You're going to start your quiz at 12. Kita kelas sampai pukul 1 kan, 10, 11, 12, 1 lah. So the last hour will be quiz period, okay?
Okay, sir.
So the quiz will be conducted via Google Classroom lah. Kamu buka dekat ongoing assessment, nanti dia akan naik satu link untuk quiz. Right, for today, we are going to discuss about this topic. Kita bincang topik ini. Okay, mechanical basis of human motion. So this topic is actually talking about kinetics. Okay, it talks about the basis of kinetics, which is force. Kita cerita force hari ni. What kind of force, what form of force we can find in biomechanics. So in order to understand about force, you need to understand the law that governing force. Okay, ataupun the law that governing what we call as motion. Apa ni kita nampak, motion is caused by force. So the law that governing or the law that being follow or obey by force is law of motion ataupun Newtonian law. Okay, where we have three Newtonian law talking about motion and force, and another one talking about gravitation. So we are going to discuss a lot of these three. Gravitation ni hanya untuk makluman sahajalah. We are not going to be in depth in this one. Okay, so the first law governing motion or talking about force is law of inertia. Ni law yang pertama. Okay, so to understand law of inertia, it talks about this one. Okay, law of inertia ni cerita benda ni. If we have an object, this object, katalah objek ni duduk dekat atas meja. So my question is simple. Objek ni boleh bergerak sendiri ke tak boleh? Can it move on its own? Boleh ke tak boleh?
Tak boleh.
Tak boleh, tak akan boleh. Tu Newton law yang pertama. Okay, so it talks about an object remain motionless. It will remain motionless. Atau it talks about an object in motion. Okay, katalah dia bergerak pada kelajuan ini, and it will remain this velocity. Okay, so first law said that unmovable object will remain unmovable. Movable object will remain movable unless there are external force acted upon the systems. So the first law talks about ini. Okay, it said that without this one, without acceleration, if we don't have acceleration, unmovable object will remain unmovable. Movable object will remain movable at a constant velocity. The word here is constant. It will remain movable at a constant velocity unless there are forces acted upon the system. So this force will cause an acceleration. Bila ada acceleration, barulah benda yang tak bergerak boleh bergerak. Benda yang sedang bergerak akan menjadi lebih laju ataupun akan menjadi perlahan. This is the first Newton law or known as law of inertia. Okay, it talks about, it said that unmovable object will remain unmovable and movable object will remain movable at a constant velocity unless there are external force acted upon the system. So if there are no external force, the system will remain equilibrium. Ini adalah konsep Newton law yang pertama. Okay, so to understand Newton law pertama ni, ini yang sebenarnya kita kena faham. Equilibrium. It comes from the root word of equal ataupun sama. Okay. So jadi objek yang tak bergerak, apa yang sama? This object does not move because there are no force moving the object. So, at any instant point of time, okay, force horizontal dia, ni force ke depan ni, kita panggil sebagai force horizontal is equals to 0. Force vertical is force something like this. Okay, force ke atas, menegak ke atas atau ke bawah. Okay, this is horizontal, this is vertical. Force vertical dia equals to 0. And the third one is force macam ni. Ataupun diagonal force. Ataupun nama lain dia ialah torque. Okay. Torque also equals to 0. This is the concept of equilibrium. Maksudnya, there are no force forward, there are no force upward, there are no force diagonally. Which cause the object unmovable. Kalau objek dah bergerak pula, it will remain movable at a constant velocity. That is Newton's first law. So the concept here, the term underlying the first Newton law is equilibrium. Jadi equilibrium ni pula kita boleh bagi pada dua. Jangan sakit kepala, senang je. Satu kita panggil the static equilibrium, another one we call it as dynamic equilibrium. Although the name static and dynamic, you know that static does not move, dynamic is moving, it still obey the same principle. There are no force horizontally, there are no force vertically, there are no force diagonally. So this is static equilibrium. This is dynamic equilibrium. Although it is moving, but it is still in a state of equilibrium. Meaning, tak ada acceleration. Bila kita cerita konsep equilibrium, force kosong semua ni, maksudnya there are no acceleration. Because acceleration cause changes. Equilibrium does not change. Equal. Itu adalah law yang pertama. Law of inertia. Body will maintain a state of rest or constant velocity unless acted by an external force that change the state. So change here is caused by only one. In motion, okay, in motion the change always caused by this one terms, acceleration. Okay, acceleration. What cause acceleration? Force. Okay, so changes of state is caused by acceleration. Apa maksud changes of state? Kalau state dia rest, it become moving. Atau change of state. Kalau state dia constant velocity, it become speed up ataupun it become slowing down. So the velocity change. That is state of change. So bila benda-benda ni berubah, meaning that the object does not in an equilibrium state. Tu cerita law of inertia. Selalu kalau zaman sekolah dulu, when we try to explain about inertia, dia akan cerita benda ni. Kita kat dalam bus, standing up, pegang railing, and when the bus move forward, you feel that you are moving backward. Ingat lagi tak benda ni? Do you still remember this thing?
Ingat.
Zaman sekolah, bus berjalan ke depan, kita tercampak ke belakang. Itulah inertia. That is the sense of inertia. So what actually changes when the bus move forward means it has an acceleration value. Cause tadi kamu tak bergerak, kamu sekarang bergerak ke belakang. Acceleration cause changes. And you notice that after a while, pergerakan ke belakang ni dia jadi semakin sedikit, and finally kamu stable balik although the bus is moving. Pernah rasa benda ni? Bas bergerak, kita berhayun ke belakang, lepas tu makin lama kita makin stabil. Semua orang pernah rasa kalau kamu pernah berdiri dekat dalam bas ataupun train. Okay. Kenapa selepas seketika, the sense of inertia is not there anymore? Simply because now you are at a new state of dynamic equilibrium. No more acceleration. Sekarang kamu berada dalam konsep equilibrium kembali. So masa kamu beralih ke belakang, there is no equilibrium. Because equilibrium being disrupt. But when you are static again, sekarang kamu dah tak rasa pun macam nak ke belakang atau apa-apa yang seangkatan dengannya, means that is dynamic equilibrium. Although they are motion, but equal motion. Means no acceleration at any direction. Okay. Itu adalah konsep Newton law yang pertama. Means kat sini yang kamu kena faham apa konsep dia. Unmovable object will not move. Movable object will move at a constant velocity. Itu konsep dia. Unless you kick on that. Okay, so kalau kita tak kick, kita tak buat apa-apa towards that object state is not going to change. Itu law of inertia. Okay, so okay, ni contoh dia. A law of inertia implies that a skater gliding on ice will continue gliding with the same speed and in the same direction bearing the action of external force. Okay, maksudnya kalau dia, contohlah kamu tengah main roller skate kan. If we neglect friction, you can actually skate sampai hujung dunia, sampai hujung masa. You are not going to stop because of inertia. If we neglect friction, but no, we don't have that in reality. Kita ada friction yang akan menyebabkan kamu semakin perlahan. But that is law of inertia. Okay. To further explain about this situation. Ni kan bola ni. Okay. To further explain about okay. Sekejap. Kenapa dia sangkut ni? Okay. To further explain about this situation when we applied force. Okay. Kosong. Ni kondisi pertama. This is the first condition. Second condition, after contact, we are going to have a certain amount of velocity. Okay. To further explain about motion is Newton's second law. Okay. Where it talks about interrelation between force, mass and acceleration. Ni. Apa dia? Force being delivered by the foot, mass of the ball and acceleration after the kick. This is the interrelation. Okay, this is the interrelation where we can have the relationship by this equation. F equals to ma, where F is force, m is mass, and a is acceleration of the object that we imply force. So from here, we can actually notice one simple thing. If we increase force, we can increase acceleration. Okay, if we increase force, we can increase acceleration. Tapi bukan itu nak dicerita di sini. Okay, Newton's second law try to talk about the interrelation. Okay, look here. A force applied to a body. Okay, force is a force, external force applied to a body, bola ke apa-apa tadi. This Newton law talks about the aftermath, kesan dia. Okay, so macam mana kesan force pada objek? Okay, simple kesan. If you have an object and we applied force, first and foremost, okay, remember this. If we applied force to an object, it will cause the object to move. Now, it talks about how much moving. Katalah, dalam vector drawing in biomechanics, when we try to show how much force is the length of the arrow. Okay, the length of the arrow determine how much force in vector drawing. Contoh, kita ada panjang macam ni. Dengan panjang macam ni. So, this force, A force, is lesser than B force. Lagi panjang arrow tu, lagi banyak force in vector drawing. And the direction of the force determine the direction of force being applied. The direction of the arrow. Kalau macam ni maksudnya force daripada bawah ke atas. Kalau macam ni force daripada condong. Kalau macam ni mean force daripada atas ke bawah. Okay. Magnitude being determined by the length. Okay. So in Newton's second law, it said that if we apply force, it will cause an acceleration. And that acceleration proportional to the amount of force. Maksudnya, kalau ini amount of force, inilah amount of acceleration. Kalau amount of force sikit, acceleration sikit. Kalau amount of force banyak, acceleration banyak. Itu maksud dia. A force will cause an acceleration. Okay. Proportional to the amount of force. Berkadaran dengan berapa banyak force kita bagi. Lagi banyak force, lagi banyak acceleration. In the same direction of the force being applied. Apa ni? Nombor 3. If the force being applied from left to right, the movement is going to be from left to right. Dia tak boleh bola macam ni kan. Faham. Dia ni. Sekejap Dia tak boleh kalau kata bola kita tu macam ni, we applied force here, bola bergerak ke bawah. Tak boleh. It's not like that. Okay. So the moving of the moving of the object is in the same direction of the force being applied. Tu ketiga. Kalau daripada kiri, bola pun bergerak kiri ke kanan. Kalau kita bagi pada atas, bola pun bergerak atas ke bawah. Okay. When we apply force, it will cause an acceleration. One. This acceleration, okay, proportional to the magnitude of the force. Sama kadar. And in the same direction of the force being applied. Itu tiga benda. Dan yang keempat, when we apply force, we are going to have another amount of force acted in different direction of the force being applied. Ni adalah poin keempat dia. Dia tahu sekejap ni. And inversely proportional to the body mass. Okay, apa maksud dia? Meaning that if we apply force to an object, body mass of this object will lawan balik. That is the sense of weight. Okay, what cause this sense of weight ni? Kita ambil bahagian ni. Statement nombor 4. Inversely proportional to the amount, to the mass of the object. Meaning that, whatever thing you do, katalah kita daripada atas pula, so you're going to have something macam ni. Kalau kita diagonal, you're going to have something macam ni. Means there will be force acted upon inversely direction, and that force is friction. Okay, is friction. Okay, jadi apa maksud dia? Ada gambar basikal lepas ke tak ada? Sekejap tak ada. Okay. Semua orang pernah kayuh basikal? Hari raya ni takkan tak pernah kot. Balik kampung nak jadi budak out kan. Okay. Pernah tak kamu kayuh basikal? Sometime you feel that when you try to pedal, it's quite hard. Sometimes when you try to pedal, it's easy. Pernah tak rasa benda tu? Nak kalau tayar tu lembik, lagi susah kita nak kayuh. Means the starting of the cycle, it become very very hard. Okay. Kenapa dia jadi macam tu? Kalau kita kata we apply force, it move. What actually happened during the cycle itself? We apply force, but the force does not cause any movement. Instead, we need to apply more force. Itulah ayat yang keempat ni. We do apply force to the object, but that object has weight. It has weight. Okay? Means that in order for us to make the object move, we need to overcome the weight. Okay. Kita ada satu kotak. We have a box. Katalah box dia punya mass 10 kilo. Okay. This is not force. When we try to convert mass into force, we are going to use weight. Okay, apa itu weight? Weight is mass time with gravity. Okay, hari ni kita ambil gravity mudah, 10. Jadi, kalau kotak 10 kilo, berapa dia punya weight? 10 kali 10. It will be 100 Newton. Okay, it will be 100 Newton. Alright. So, now, saya tukar dia jadi Newton. Newton ni bergerak ke mana? It will always move this way. And it will always move in the direction of force being applied. Okay. Katalah, kita apply force dekat sini 50 Newton. Can we make the box move in this direction? Boleh tak?
Tak boleh.
Kenapa?
Sebab dia tak cukup. Tak
Sebab
apa.
dia tak cukup. Sebab
Ya.
dia tak cukup. That is true. Sebab dia tak cukup. Kenapa kamu kata dia tak cukup? How you know dia tak cukup? Okay. That is the fourth statement. Inversely proportional to the body mass. So, any body in the world will have mass and weight. If you try to move the object and the force being applied is less than the weight of the object itself, it does not move. Tadi kita cerita, kita bagi force tu akan menyebabkan benda bergerak. Sama direction to the force. Sama power dengan force. Tapi sekarang kenapa tak bergerak? Because of weight. So, how much force need to be given in order to make this box move? Berapa banyak force kita perlukan? How much do we need in order to make it move?
Atas 100.
Ya betul.
101.
Atas 100 senang ke? More than 100. Even 101 pun, it can move. Tapi slow lah kan? Kalau kita bagi dia 200, dia move lagi laju. That is the meaning of Newton's second law. Okay? When we apply force to an object, it will cause the object to move. Macam mana movement dia kriteria in the same direction of the force being applied? Proportional. Magnitude is proportional to the amount of force being applied. And then, finally, inversely proportional to the mass of the object. Meaning, kalau kita bagi 10 Newton, janganlah harap dia bergerak 10 Newton because it has mass. So, you need to overcome the mass in order to move the object. Tapi, pergerakan dia bila kita nak cerita, it obey Newton's second law. Apa maksud obeying second law? If we apply force, it will cause object to move. Itu yang pertama. Okay, it will cause. And what cause the movement? This one, acceleration. It cause changes. So if the ball does not move at the first point, when we applied force, it cause acceleration. It cause the ball to start moving. Kalau bola tu sedang bergerak 2 meter sesaat, kita tambah lagi sepakan di belakang ni, it will cause the ball to travel faster. Itu maksud dia. Okay. Applied force, it cause the object to move. 1. Moving magnitude, proportional to the amount of the force. 2. Direction of the movement, according to the direction of the force being applied. 3. And number 4, inversely proportional to the amount of mass of the object itself. Maksudnya, kita akan ada satu lagi yang bergerak daripada depan known as friction. Okay, overcome this friction, the object will move. Okay, kejap lagi kita cerita friction. Kita cerita law dulu. Okay, itu adalah Newton's second law. Okay, when a ball is thrown, kicked or struck with an implement, it tends to travel in the direction of the line of action of the applied force. Greater amount of force, greater the speed. Okay, this is the relationship. Alright. Ni contoh dia bagi dalam pengiraan lah. If 1 kg ball is struck with a 10 Newton, the resulting acceleration of the ball is 10 meter per second. If the ball has a mass of 2 kg, the application of 10 Newton, sekarang tadi bola dia ringan, so dia dapat 10. Kalau bola dia berat, acceleration dia jadi perlahan. Okay, so dia simple. Simple je belajar ni. Makna dia gini. Ini bawah. Okay, maknanya gini. Katalah force kita constant. Kita ada 50 Newton. Okay, and then objek tu pula 100 susah no. Kita ambil satu nombor 5 kg. Okay, berapa acceleration ni? We try to find the acceleration. So, let's find out the first one. Okay, kita ada M1. M2 pula barang dia jadi lagi berat 10 kg. Okay, so sama dengan 5A. Jadi A sama dengan 50 bahagi 5. Acceleration untuk objek pertama ialah 10 meter per saat square. Okay, acceleration untuk objek kedua, we have 50 equals to 10A. A equals to 50 bahagi 10. We have 5 meter per second square. Okay, ataupun kita tengok benda macam ni. We have object. Okay, we have object and this object accelerate. Sekejap, kita nak tengok. Okay, kalau kita ubah F. Okay, tadi kan kita buat equation. If we increase F, A akan increase. Okay, katalah bola ni berat dia 500 gram. Equals to 0.5 kg. What happen? Okay, what happen if we apply 100 Newton kepada sistem? Okay, so kita ada A 100 bagi 0.5 berapa 20, is it? Okay. 200 meter per saat. Apa jadi kalau kita increase force ni? So, instead of 100, we increase to 200 Newton. equals to the same ball A equals to 200 bagi 0.5 400. This one prove that if we increase force, the acceleration of the object increase. Ini Newton's second law. Paling mudah. Okay. Bagi force, it cause acceleration. Acceleration cause movement. Lagi banyak force, lagi banyak acceleration. Itu dia. Okay. Itu adalah Newton second law. Acceleration macam mana? Samalah direction dengan force tadi. Acceleration macam mana? Samalah banyak dengan force yang diberikan tadi. And then we have inversely proportional to the amount of mass of the object. Okay, that is Newton's second law. Newton third law. Ini yang paling simple. Ini yang paling simple. Soalan dia paling susah. Jawapan dia paling senang. Take a good look. Okay, take a good look now. Third law talks about law of, dia ada satu lagi term kat sini, action reaction. Okay, the third Newton law is better known as law of action reaction. Nama mudah dia saya selalu bagi ni dia. What you give, you get back. This is Newton's third law. Okay, to understand Newton's third law, I will recall Cartesian coordinate. Do you still remember this coordinate? Y, X. Anything that move from left to right is positive. Anything that move from right to left is negative. Anything that move from bottom up is positive. Anything that move from up, okay, to bottom is negative. Apa benda yang move ni? Kita cerita tentang force lah. Okay, kita cerita tentang acceleration, all of these things. Okay, so law of action reaction is something like this. If we apply force to the ground, ini force positive ke negative?
Negative.
Okay, if we apply force to the ground, at the same instant of contact, the ground will inflict the same amount of force, but in different direction. Amount is equal, the direction is different. Ini law of action reaction. Okay ni. For every action, there is an equal and opposite reaction. In terms of force, the law may be stated as follows. When a body exerts a force on a second, the second body exerts a reaction force that is equal in magnitude and opposite in direction towards the first. Okay. Contoh paling mudah. Kita ambil 100 meter sprint start. Okay. Pakai starting block. You are going to see some athlete have a good thrust forward. Dia melonjak tu jauh. But some others, although the starting block is similar, dia punya jump dekat je. Dekat je. Ataupun kita tengok swimming. Okay, ada orang bila dia start jump daripada starting block tu, it goes quite a distance. But not to others. Okay, why it happen like that? It's because of law of action reaction. Okay. The first jumper, okay, this is just hypothetical. Katalah dia apply 200 Newton towards the starting block, so it will return back to the to the runners 200 Newton, but in different direction. That's all. Ni 200 Newton punya thrust. Maybe the second athlete just put a fraction of thrust, causing it to return the same amount of thrust. Jadi hasil ni kita nampak lonjakan kurang berbanding lonjakan first athlete. This is Newton third law. Jadi law in the world, in our galaxy, law of motion governing all type of motion we have, and all type of motion following all these three law. Okay, number one, if there are no force, object will remain unmovable. Dia tak boleh tiba-tiba bergerak sendiri. Itu maksud dia. Kalau objek yang dah bergerak, dia tak boleh berubah pergerakan. Second, if we apply a force to an object, it will cause the object to move. Ni dah sambung cerita pertama tadi kan. But the second law, it talks about the properties of the movement. Force cause acceleration. That acceleration is at the same magnitude as the force being applied. at the same direction as the force being applied. Tu dia punya bentuk It will cause movement and it will has inverse effect towards the mass of the object. Law yang kedua. Law yang ketiga, what you give, you get back. Meaning, if you try to have more outcome, give more force. We cannot expect lompat-lompat, main lompat-lompat bertiga jam kan. Lompat kecil, efek tinggi gila. Tak ada. Ataupun kita buat standing broad jump, we don't have the run up. We just stand there and jump. Don't expect you to have jump as long as triple jump punya orang. Takkan dapat. Because of law of action, reaction. If you try to have more outcome, give more input, and then you're going to excel, because that is how force works in our life, in our world. This is 3 Newtonian law that governing motion. Okay, jadi law yang keempat ni, ni contoh dia lah. Contoh dia ambil mudah kat sini. 90 kg rugby player ni, Mamat ni. Berlanggar dengan 80 kg rugby player ni, Mamat ni. Kalau this player exerting 450 Newton, how much force being exerted by the second one? Kalau player ni dapat 450 Newton daripada pelanggaran ini, how much force exerted by second player? 450. Positif ke negatif?
Negatif.
Negatif. Pasal yang ni positif. Tu je. Senang. Okay, itu saja kalau soalan dia tentang force. Okay, this is about force. Alright. So jawapan dia mudah, negatif. Pasal satu tadi dah positif, satu lagi negatif. Opposite direction of force. Okay. So law yang keempat ialah law of gravitation. This is just for your knowledge. Okay, this is just for your knowledge. Before this, what we know about gravity is everything being pulled to the surface of the earth. Tapi sebenarnya, in law of gravitation, all body are attracted to one another with two simple rules. Satu, with a force proportional to the product of their masses. Lagi besar, lagi banyak gravity kita. And number two, inversely proportional to the distance between them. Maksudnya, inverse proportional. Distance jauh, force kuat. Distance dekat, force perlahan. Ni masuk gravitation. Okay, konsep mudah. Kita, manusia ni terdiri daripada banyak jirim. Atom. And this atom is attract to one another. That is gravity. Okay, that is gravity. Bumi pun ada atom di sini. But, if we compare manusia dengan bumi, okay, the mass of the earth is larger compared to the mass of the human. Means that bumi have more greater amount of gravity compared to manusia. So, siapa yang lagi besar, lagi kuat gravity dia, dia akan tarik benda yang lebih kecil. Ni konsep lah, konsep asas untuk gravitational force. So, this is just for your knowledge. Okay, alright. So, we are going to have a break, just a bit of break, and we are going to start again at 10:45 regarding mechanical behaviors of body in contact. Ni semua adalah force dalam bentuk berbeza. Okay, we are going to meet again in 10:45. Thank you. Okay, the first mechanical behavior of bodies in contact, bila satu benda berlanggar. Okay, bila benda berlanggar. Okay, contact here, in contact ni, kamu jangan bayangkan berlanggar, berdentum sahaja. When we try to apply force to an object, berlanggar. Ni in contact. Meaning here, when a force being transferred. Okay, when a force being transferred, it can transfer in several forms. Okay, the first one in terms of friction. Okay, so friction is a force acting over the area of contact between two surfaces. Kita ada objek, kita sepak. Okay, this object will always remain on a certain surface. So there are force acted here, which being explained in Newton's second law. Mass inversely proportional of the mass of an object. Mass of an object 100 Newton. Okay. Bila kita apply force 100 Newton, dia tak bergerak. Simply because there are mass and there are force that work inverse direction, which is known as friction. Okay, which is known as friction. Friction ada macam-macam jenis, but for your level, we are going to talk about surface friction. Friction between two surface. Okay, this friction, contact between two surface in direction opposite to the motion, magnitude of the generated friction force determine the relative ease or difficulty of motion. Alright. So to talk about friction, contoh macam ni. Bila kita tak tolak benda, there are no friction because there are no force acted upon the system. But when we apply force, there will always be friction. And this friction will be inverse direction. Newton's second law. Okay. Alright. So to talk about friction, we need to have two properties. Okay. Bila sesuatu benda tidak bergerak, there will be friction in between the surface, contact surface. So kalau petak dengan bulat, contact surface berbeza, amount of friction berbeza. Okay, itu yang pertama. When we talk about friction, there are two types of friction that always occurs in motion. One is known as static friction. One is known as dynamic friction. Okay. Kadang-kadang kamu jumpa simbol macam ni. You have an inverted U. Kalau huruf U macam mana? Macam ni kan? Ni inverted U. Balik. Okay. Kadang-kadang you see something like this, and sometimes you see something like this. This is static friction. This is dynamic friction. Okay, itu yang pertama. And then, what is the difference between static and dynamic? Let's say objek ni tidak bergerak langsung and we applied force. Do you ever feel like this? Contoh kan, kita nak tolak, okay lah, kereta kawan rosak, so you try to push the car down the road. When you start to push the car, you're going to feel a certain amount of weight. But when the car start rolling, the weight, the sense of weight reduce. Pernah rasa tak benda tu? Kita nak tolak kereta, rasa berat. Tapi bila kita dah start tolak, dia dah jadi sedikit ringan. Do you ever feel that?
Ada, sir.
Okay. Masa dia berat tu, that is the state of static friction because there are no motion yet. But when the object is in motion, dia dah bergerak, you feel that it become lighter because of itu kita panggil sebagai dynamic friction. Berat objek tak berubah, but the amount of friction reduce. Static friction usually higher compared to dynamic friction. Static usually dia macam ni. Dynamic. Kalau static 0.8, dynamic ni selalu 0.6 something. But the figures is going to be less than 1 lah. 1 if full friction. Okay, it will be less than 1, and dynamic friction is lesser compared to static friction. So in order for us to determine how much friction we have in an object, kita kena kira dia punya net force. Equals to force time with coefficient of friction. Tak kisahlah static ataupun dynamic. And force here is ni, weight dia. Okay, so example. Okay, for example, kita cerita friction. Kita ada satu kotak yang mass dia 10 kilo tadi. Okay, so automatically weight kotak ni is 100 Newton, 10 kali 10. Okay, let's say if the static friction coefficient is 0.75, how much force is needed in order to make the box moving? Berapa banyak force yang kita perlukan untuk gerakkan kotak ni? To do so, we need to determine how much net force the box has. So, to find out net force equals to force time with coefficient. Sama dengan 100 time dengan 0.75. Sama dengan 75 Newton. This is the net force. Okay, meaning that the weight of the object plus the coefficient of friction come out the net force. Jadi berapa banyak force yang kita perlukan untuk menggerakkan kotak ini? It will be more than 75 Newton to start moving the box. Okay. And then when the box in motion, the dynamic friction is 0.56. Kita kata punya tu lah. So how much force is needed in order to keep the box moving? Kotak dah bergerak. Sekarang berapa banyak force kita perlukan untuk kekalkan gerakan. So we need to find out the new net force. Equals to 100 times with 0.56 coefficient of dynamic friction, which resulting 56 Newton. Means in order to keep the box moving, the force needed need to be more than 56 Newton. Now you can see the difference. To start moving, you need 75 Newton. To keep on moving, you just need 56. It is because static friction and dynamic friction is differ. When the box is in motion, when the object is in motion, the friction will become less. Tapi tadi kita cerita kalau box tu 100 kg, kita perlukan lebih daripada 100 kg Newton. But now why it become less? Because of friction, because of surface. So there are some surface which is quite slippery. There are some surface which is quite rough. At rough surface, more force is needed in order to overcome that friction. In slippery surface, less force is needed in order to make the object moving. Ni cerita friction, bentuk force yang lain which is friction, a force that works when there are external force acted upon the system only. Baru kamu dapat friction. Okay. Okay, friction.
Okay.
Alright, ni friction Okay, contoh macam ni dia bagi FA, FM ni maksud dia apa? Kalau friction, maximum friction is coefficient tadi lah. Kalau kata friction, force yang kita bagi sama je dengan amount yang kita ada, friction yang kita ada, takkan ada pergerakan. Ni lah benda ni This is contoh kalau kita punya ni 75 Newton, that is the net force net yang ada. Kita membagi 75 Newton in term of force, in term of acceleration, tak bergerak lah benda ni ke mana-mana because it equalize. So in order to move, we need to have force over the amount of maximum friction ataupun net force of the system itself. Okay, this is friction. Ni contoh kalau bergerak, maksudnya force being applied is more than friction that you have. Okay. First friction. Lepas tu masuk momentum terus sekejap tengok tajuk dia. Okay, momentum and impulse. Okay, so the second one, the second and the third properties, okay, of force is about momentum and impulse. Okay, I'm going to talk about these two together. Impulse, okay, ialah, okay, impulse ni kita boleh tulis, we can write impulse in this equation. Capital I equals to Ft, where I is impulse, F is force, and T is time. Okay. So apa itu impulse? Impulse is the amount of force being given to an object in a period of time. Okay. So when we have impulse, we are going to have momentum. Momentum. Or we can write it as capital M equals to a small caps M and small cap V. This is momentum. This is mass. This is velocity. Or in other words, momentum is the amount of movement. How much movement you have? Momentum. Okay, how much movement an object have momentum. Is momentum. So kalau benda tu bergerak lagi laju, that object has more momentum. If benda tu bergerak perlahan, that object has less momentum. Okay, and these two things is equal, meaning that at any given point of time, in a moving object, you're going to have these two things because I will always equals to M. Maksudnya lagi banyak impuls kita bagi, lagi banyak pergerakan. Ini sama je sebenarnya. Do you still remember this one from the earliest topic? Lagi banyak F, lagi banyak E. Banyak force kita bagi, banyaklah acceleration. Force in a raw form. When we have contact, we transfer impulse. Impulse cause momentum. Okay, pasal tu saya nak cerita benda ni sekaligus. Impulse always equals to momentum. Okay, why it happen like this can be further described by impulse momentum theorem. Okay, apa impulse momentum theorem kata? It talks about this thing. F equals to MA. Okay, if we write out A in much longer version of it, you're going to have F equals to M V2 minus V1 over T2 minus T1. Dia akan jadi benda macam ini. Alright, now let's transfer this part to left hand side. You're going to have F T2 minus T1 equals to M V2 minus V1. Okay, in mathematical equation, when we have this thing, 2 minus 1, meaning that times time 2 minus times time 1, ataupun final time minus initial time, means here we try to see the difference. Okay, we try to see the change of. So it can be write out as F, the change of T equals to M, the change of V. Tengok balik ke atas. F T is this one. M V is this one. Which makes from the F equals to MA, we can have I equals to M. This is impulse momentum theorem. So based on this, we know that if we increase impulse, we are going to increase momentum because more force causes more acceleration at the first place. So by impulse momentum theorem, we can come up with 4 different equations. Number 1, I sama dengan FT. Ini equation pertama. Number 2, M equals to MV. Number 3, since I equals to M, so impulse also equals to MV. And number 4, since M equals to I, momentum also equals to FT. Jadi kita boleh tunjuk dekat sini, sama je impulse dengan momentum tu. Because when we give impulse, bola, kita sepak, when things collide, this is called a collision. Pelanggaran between kaki dan bola. At a point of collision, we are going to have impulse. And this impulse will cause the ball to move. A moving object will have momentum. So if we increase the amount of impulse, the ball is going to travel further and faster. Ini kaitan antara impulse and momentum. Okay, impulse and momentum. Okay, contoh penggunaan dia macam ni. Katalah kita ada bola. Okay, so kita pun sepak bola ni. We kick the ball. Let's say the force being applied is 100 Newton. And the application, okay, application. Kan tadi kita ada I equals to FT. This T is the time contact. Okay, time contact ni, mana budak yang baru masuk? Tak ada. Okay, time contact tu, kalau kata kita buat high speed camera, when we kick the ball, okay, try to see my hands here. When we kick a ball, dia bukan kick bola terus gerak, but when we kick a ball, you're going to have a time where the leg is going to have complete collision with the ball, and we're going to have a certain movement before the ball start to separate and go. So the time contact is the time between the first contact until the first let go between these two system. Mungkin masa dia tu tak panjang, it's just a millisecond. Okay, it's just a second or millisecond. But that is the time that we have interest here. Okay, so let's say the time of contact for this action, is 1 second. Okay, so how much impulse we have here? Kita kira itu dulu. Okay, so impulse equals to ft, f equals to 100, t equals to 1. So kita ada 100 Newton per second of impulse here at contact. So now the question is, with 100 Newton per second of impulse, how fast the ball can go? Let's say the mass of the ball is 0.5 kg, 500 gram. Sekarang kita nak cari berapa pula momentum dia. How much V? Okay. Since we know that I equals to m, so the starting momentum here will always equal with the amount of impulse being given. So it will be 100 Newton per second equals to 0.5 kg and V. Jadi V ialah 100 divide by 0.5. Berapa ni kita dapat? 200 200 meter per second. This is how we play around. We play along between impulse and momentum. Okay, so when an object being given an amount of impulse, it will cause the object to move. Meaning dia akan ada velocity, dia akan ada momentum. So we can find out the momentum based on force. Okay, katalah pula macam ni. Kita terbalikkan. We have a bowling ball. Okay, we have a bowling ball. Bowling ball selalu berat berapa kg Anybody playing bowling here? Can you guess the weight of the mass of the bowling ball? Berapa mass dia? Wih, korang semua tak main bola, tak main bowling ke?
14 ada, 15 ada.
Dia tu pound kan?
Pound sir.
Okay, unit converter. Kita ambil yang ringan lah, 14. Tu benda lah, weight. From pound to kilogram. 14. 6.4 kg. Okay, berat agak weh, nak baling bola 6 kg. Macam baling beras. 6.4 kg. Okay, let's see. This ball now travel at 10 meter per second. Okay, it travel at 10 meter per second. Can we know how much force being given to the object? Ni kan, force ni kita nak tengok ni, masa dia nak bola bowling tu, berapa banyak masa yang dia ambil untuk lakukan berapa banyak force being delivered by this hand during this action. Let's say this action, the time taken is 1.5 second. Berapa banyak force in order to get this kind of motion. So for this kind, it actually inverse with our first problem. First problem kita start dengan force, kita nak tahu berapa laju. Now we know the laju, we don't know how much force being produced. Okay, we can use momentum equation to start this one. Equals to mv equals to 6.4 10 equals to 64 Newton per second. So this 64 Newton per second is momentum. Same as impulse. Pasal impulse sama dengan momentum. So impulse pula equals to Ft. We try to find the F. So impulse dia 64 Newton per second equals to berapa tu? F 1.5. So F, it will be 64 over 1.5. 43 Newton. Can we speed up the ball? Yes, speed up the force. Increase the force. Okay, let's say kita ambil 50 Newton je. F equals to 50. So now let's find out the new velocity of the ball. Okay, I equals to Ft equals to 50 times 1.5 equals to 75 Newton per second. So now this is the new momentum. Tadi momentum dia 64, sekarang 75. So momentum equals to mv, the weight of the mass of the ball does not change. 75 equals to 6.4 v. So v is 75 over 6.4. Now the ball travel at 11.7 meter per second. More force being given, more velocity. So this one proves that impulse play a major role in determining momentum of the object. Inilah dua properties yang saya nak ceritakan sekaligus tadi. Okay, this one, momentum. Factor that affect the outcome of interaction between two bodies is momentum. Momentum can be defined generally as the quantity of motion. Tu momentum. Okay. So static object tak ada momentum because velocity kosong. Velocity kosong, momentum kosong. Okay. And then ni contoh dia. Okay, we cover this one by our example. Ni contoh lagi satu. Okay, alright. Ni saya skip dulu yang ni. Jadi saya tunjuk balik. This is conservation of momentum. Kita tengok impulse. And impulse pula, okay, when external force do act, they change the momentum present. So impulse is the cause of momentum. Change of momentum depends on the length of time. Length of time benda yang kita cerita tadi lah. Jadi macam mana kita nak naikkan impulse? How we want to increase impulse? Let's say our force production is maximum. How we want to increase impulse? Play with the time. Okay. In real life, time, especially in sports, okay, sports, how we want to play in time is actually by having full range of motion. Full ROM, longer period of time. With the same amount of force, you are going to get more impulse. Okay, ini impulse momentum theorem. We have discussed this one. Okay, so we go back to here. Sebelum kita masuk impact. Impact is the last one. Ni, saya nak cerita ni. Okay, this is the concept of this is the concept of momentum conservation. Okay, apa maksud momentum conservation? Momentum conservation play a major role in contact sport. Bila kita ada dua benda collide with one another, it will become one system. Okay, this is system A, this is system B. System ni satu benda lah. And bila dia berlanggar, it will become a new system. Contoh macam kereta kan, kereta, bas, berlanggar dengan traktor. So lepas dia berlanggar, bas tu mungkin tinggal separuh, traktor tu pun separuh. Tu maksud dia. Okay, when people collide, when an equipment collide, it will form a new system. Okay, cumanya in any given point of time, momentum of the system will actually being conserved. M3 ni ialah momentum 1 tambah momentum 2. Momentum takkan hilang. It may change in term of shape. It may change in terms of mass. It may change in terms of velocity. But it won't dissipate. Okay, maksud dia macam ni. When we talk about momentum, kan kita ada M1. Momentum is mv. Betul? Okay. So if we have two object, we name it is object 1 and object 2. So dekat sini pun akan ada mv. Dekat sini pun akan ada mv. Okay, ni yang pertama Momentum 1 plus momentum 2, it will always equals to a new complex. Still sama. Okay. Ini gabungan 2. Jadi M. Yang ini V. But it's still same. MV equals to momentum. MV equals to momentum. MV equals to momentum. So this is what we call as principle of momentum conservation. Okay. Kalau sini ada 1000 momentum, sini pun akan ada 1000 momentum. That is the meaning of it. Okay, that is the meaning of it. Remember that. If the momentum before is 1000, momentum after is also 1000. Tapi, apa yang berbeza? The shape is going to be differ lah. Tadi kita ada dua benda kat sini, dah jadi satu. Because it collide. Okay, so contohnya, kita ada orang tadi. Okay, orang 90 kg. Orang 80 kg. Satu bergerak ke sini, satu bergerak ke sana. So, after dia berlanggar, kamu tetap akan ada dua orang. Satu 90 kg, satu 80 kg. Okay. Kamu akan ada satu kompleks. Tapi velocity dia mungkin berubah because it try to remain the same. Itu maksud dia. Okay. Katalah orang ni bergerak pada kelajuan 4, orang ni bergerak pada kelajuan 4.5. Kita nak tahu lepas dia berlanggar berapa kelajuan baru dia. Okay, so you need to find out M1 V1 plus M2 V2 equals to M1 plus M2. This is the new complex V. Cuma, when we talk about momentum conservation, remember, ni, Cartesian coordinate. Yang ini dia takkan cakap. Dia just cakap je 4.5 saat, seorang lagi 4. Tengok pergerakan dia. The first person move from left to right. So this one is positive. Second person move from right to left. This one is negative. You forget to include these marks, you're going to lose everything. Equation ni akan jadi salah. Okay, tengok. M1 90, V1 4 plus M2 80, V2 negatif 4.5 equals to 90 plus 80 V. Okay, 9 kali 4 360. 8 kali 4.5. Apalah cari nombor susah-susah. 36. So tambah dengan, is it true? Betul. 36 sama dengan 170 V. 360 tolak tolak 360. Kita dapat kosong. So kat sini pun kita dah tahu dah. V sama dengan kosong. Tapi if you forget to put down minus here, kamu akan end up dengan 720. Where V dia ialah 720 bahagi 170. 4.2. Nampak tak perbezaan? The difference where you have put in the correct direction and without the correct direction, it will give you a different answer. So when we talk about momentum conservation, when we talk about collision, the case of pelanggaran dua benda, always remember the one that move from right to left is negative in terms of velocity because it move at that direction. And then only you can come up with a good outcome, or else Dia jadi macam ni. Apa maksud dia V sama dengan 4.2? After collision, dua-dua ni bergerak ke sana. Itu maksud dia. Kalau kita dapat negatif pula, meaning selepas pelanggaran, dua-dua bergerak ke kiri. If we end up kosong, means lepas pelanggaran, dua-dua static dekat tempat mereka. Tak bergerak ke mana-mana. Because the momentum is equalized. This is momentum conservation. This is a case of D. Ni. Okay, satu berlanggar. So, lepas berlanggar, apa terjadi? Siapa yang menang? So, we need to find this momentum. We need to find this momentum. And then only kita boleh dapat the new complex momentum. Ini adalah principle of momentum conservation. Conserve. Dikekalkan conservation. Okay. And last one is about impact. Okay. Impact is collision, pelanggaran. Okay, tadi impact. So, impact, transfer, impulse. Ingat tu. Impact, transfer, impulse. So, impact can be defined in two different forms. One is known as elastic impact. Another one is known as plastic impact. Okay, apa tu elastic, apa tu plastic? Tengok elastik je. Plastik ni kadang-kadang, plastik macam plastik bag ke? Tak. Okay. When you see elastic, meaning after collision, both object retain the actual shape. Impact of a tennis ball with hard surface. Tennis ball jatuh, berlanggar dengan lantai and bounce back. The tennis ball still in the shape of a tennis ball. Itu elastic impact. Kalau plastik ni, kita bayangkan tadi tennis ball, now watermelon. Jatuh atas lantai. Bam. Pecah. Meaning, after collision, one of the object will change totally in term of structure. Itu plastic impact. Okay, so elastic impact. Ni. Approach perfect elasticity because the ball speed diminish little during its collision and then it retain the same shape. However, for plastic impact, okay, impact resulting in the total loss of system velocity means that the speed change, the shape change at total. Itu plastik. Okay, elastik, ingat getah, tarik, kita lepas, dia kembali asal. Meaning, it retain the amount of force, it retain the original state. Plastik, tadi getah, now benang. Tarik, dia putus. Meaning, the amount of force dissipate, the shape change totally. Itu ialah plastic and elastic. And to describe this, whether the collision is plastic or elastic, is by consulting the coefficient of restitution. Tadi kita ada static and dynamic coefficient. Now, coefficient of restitution. Coefficient of restitution is number. It's just a number, like dynamic and static friction coefficient. Okay, it is just a number which describe to you whether the collision is plastic or elastic. And this number, okay, number ni, coefficient ni, dia ada dua je nombor dia. Sorry, bukan dua. Dia ada range of numbers between these two. 0, 1. Dia akan duduk tengah-tengah. Kalau dia kosong terus, that is kosong terus, perfect plastic. Kalau 1 terus, that is perfect elastic. So kalau nombor dia lagi kecil, dia menghala ke arah plastik. Kalau nombor dia lagi besar, dia menghala ke arah elastik. Okay, so most of the time, numbers dia ni, okay, ni number dia ni. Most of the time, number dia takkan dapat 0 or 1. Dia akan dapat macam 0.8, 0.7, 0.13. So if the number nearing to 0, meaning we know that the collision become more plastic. But if the number become larger, nearing to 1, the figures, okay, we know that the collision is more elastic. Okay, so dia punya equation ni kita akan pakai yang ni lah. Okay, ni this is the coefficient of restitution. Okay, so kita ada U dengan kita ada V, relative velocity after impact, relative velocity before impact. Okay. U dengan V ni pula, tengok betul-betul, kita ada V1, U1, V2, U2. Okay. V dengan U. 1 dengan 2. Tengok apa beza dia. 1 dengan 2 ni objek. Objek 1, objek 2. Okay, objek 1, objek 2. V dengan U, U is initial. Okay, initial velocity. V is final velocity. Okay, kita ada dua benda. Dua benda dan dua ni ada contoh ada bagi. Okay, sekejap saya cari satu contoh untuk kamu regarding impact. Sekejap. Ni berat sangat ni question ni. Sekejap coefficient of restitution. Okay, we have it here bawah kinetics. Okay, ini significant. Alright. Okay, katalah kita ada kita ada satu bola. This ball being dropped at this height. Okay, and then it bounced back to a certain new height. Okay, what is the coefficient of restitution? Right. So please restitution. Okay. Please jot down this one. Okay, kita ada where's the notes? Okay, ni adalah satu formula dia where we have negative E equals to UV V2 V2 V1 V2. Ni dua cara untuk kira dia. Minus V2 U1 minus U2. This is one of the way. Another way, we can have it by this equals to height bounce bagi dengan height drop and square root kan. Ni dua cara dia. Okay, this is two ways. Kalau macam yang ini, dia bagi contoh based on bounce. Okay, based on bounce rate, so kita akan pakai yang ini. Kalau dia bagi laju, turun, laju, naik, dua objek berlanggar. Okay, sebelum berlanggar berapa, selepas berlanggar berapa, kita akan pakai yang pertama. Ni dua cara dia lah. Dua formula. Dua bentuk formula in order to find out coefficient of restitution. So let's try this one. Okay, kita akan pakai equation yang kedua because it talks about the difference in bounce rate. So kita akan pakai height of bounce, which is 0.98 divide with height of drop 2, and then kita square root kan. Eh 0.98 square root 0.7. So 0.7 meaning dia dah menghampiri kepada 1 lah. So this system is underwent plastic collision. Elastic collision. Pasal menghampiri 1, 0. So here plastic, here elastic. So this one is nearing to 1, means that the collision is partly elastic. Lagi tak contoh lain. Ball thrown initial. Tadi lah 1. Okay, itu ialah collision. So dekat collision ni, kamu kena faham, we can, if we try to determine the type of collision, we need to use coefficient restitution, which will talk about the figures between 0 and 1, where if the numbers is nearing to 0, katalah 0.13, nearing to 0, the collision is much more plastic. Nearing to 1, the collision is much more elastic. So if elastic, we have two properties: retain energy and retain shape. Okay, plastic loss total energy, and we have change of shape. Ini adalah yang terakhir. Mechanical bodies of force, meaning that how we can describe force in real nature. Okay, so kita ada the first one, friction, and then we have impulse, we have momentum, and finally we have impact. Okay, where we can divide into plastic impact and elastic impact. Okay, alright. So I'm going to leave you now. Now is 11:30. You have another half an hour before the first quiz start. So your quiz will start at 12 until 1, and it is one attempt only. Okay, 10 question objective. So please finish it up before 1 p.m. Okay, the link will be given through Google Classroom at 12 p.m. Okay, ada soalan?
Sir, boleh terangkan balik yang pasal yang theorem tu?
Theorem impulse momentum. Okay, baik. Impulse momentum theorem, it is actually a theorem that talks about the relation. It talks about the relation between momentum dengan impulse. Okay, and these two things, saya keluarkan kat sini impulse equals to Ft momentum equals to mv. Okay, these two things come from the first equation of motion, F equals to ma. Okay, so impulse talks about F, acceleration talks by momentum. Okay, so dalam biomechanics, if we try to find A ni, it can be written as velocity final minus velocity initial over time final minus time initial. Ini adalah bentuk asas A. Okay, so in impulse momentum theorem, it starts with Newton law of equation. Force equals to mass times with acceleration. Okay, and then kita kembangkan equation ni. M A, kita ambil bentuk asas dia, V2 minus V1 over T2 minus T1. Okay, untuk permudahkan lagi equation ni, we are going to send this part to the left hand side. Bila kita send to the left hand side, dia akan jadi macam ni. F T2 minus T1 over 1 equals to M V2 V1 over 1. Ni bila over 1 ni kan kita boleh padam dia. It will become F T2 minus T1 equals to M V2 minus V1. Okay, next one. In mathematical equation, bila kita ada macam ni, A2 tolak A1, C2 tolak C1, kita ada tempat akhir tolak tempat awal. Bila kita ada macam ni, kita boleh mudahkan to be the change of A. Segitiga ni melambangkan the change of, meaning that times 2 minus times 1, time 3 minus time 2, time 4 minus time 3, time yang depan minus time yang belakang, ataupun benda yang depan minus benda yang belakang, the same benda. Same goes here. Dia boleh jadi the change of C. Bila kamu nampak macam ni, katalah kamu nampak change of X, maksudnya X2 minus X1. Itu maksud dia. Okay, so here is the same thing, right? T2, T1, and V2, V1. Jadi kita boleh tulis dia sebagai the change of T sama dengan M, the change of V. Okay, kita dah sampai sini. F, the change of T equals to M, the change of V. Okay, F change of T ni ialah ni. M change of V ni ialah ini. Nampak? Sama tak? Is it similar?
Yes, sir.
Yes. So, based on this one, we can come up with conclusion. Kalau F change of T equals to M change of V, impulse is equals to momentum. Okay, ni maksud impulse momentum theorem or relation. Okay, relation ataupun derivation of impulse and momentum. And by knowing this, we can come up with, kamu dah tahu dah kalau I equals to M, I ialah FT, M ialah MV. Since I equal to M, macam ni pun boleh. I pun sama dengan MV, M pun sama dengan FT. So, kamu dah boleh guna banyak untuk selesaikan masalah. Punca dia, F equals to MA. So, by knowing all of this, we can prove that by increasing force, we can increase acceleration. Why? Because by increasing force, kita akan increase impulse. By increasing impulse, kita akan increase kan hasil dia, momentum. Sepak bola perlahan dengan sepak bola laju. Sepak bola perlahan cause the ball to move perlahan. Sepak bola laju cause the ball to move laju. This is impulse momentum theorem. Okay. And then I said that I equals to FT. Okay, let's see. Kita ada force limited 100. Dah tak boleh naik dah. Macam mana kita nak naikkan impulse? We play around dengan T. Contoh, kita ambil dua sepak bola. Okay, orang pertama sepak macam ni. Orang kedua sepak macam ni. Okay, contact. This is different ROM. Untuk buat yang ini, maybe let's say 0.7 saat. Untuk buat yang ini, 1 saat. The difference is only 0.3 second. Okay, now let's find out how much impulse. Impulse, ni kita nama A lah. Impulse A, F100, T 0.7. Hasil dia 1, 2, 70 Newton per second. IB, force sama 100. Time taken 1 equals to 100 Newton per second. Difference of 3 Newton per second resulting an excess of 30 Newton per second. Okay. Now, based on here, kita jadikan dia impulse momentum theorem. If the ball is 0.5 kg, what happened to the first ball? Kita tengok dia punya berapa momentum bola A. So, momentum A equals to mv. Kita nak tahu berapa velocity dia. Jadi, ma berapa? Samalah ni. 70. Because momentum will always equals to the amount of impulse. Berapa mass? 0.5. Berapa V? Kita tak tahu. Okay, kita nak cari V ni. So, V sama dengan 70 bahagi 0.5. Yang ini pula, mb equals to mv 100. 0.5 V. So, V equals to 100 bahagi 0.5. So, now let's find out the first one. We have 140 meter per saat. And let's find out the second one. We have 200 meter per saat. Just a mere 0.3 second. Benda yang kita tak sedar pun. Resulting speed difference almost 60 meter per second. Ni impulse momentum theorem and how we play around with it. Okay, boleh?
Boleh, sir.
Alright. Okay,
Thank you, sir.
ada soalan lagi? Tak ada? Okay. So, kalau tak ada soalan, you may have a bit of time on your own to do some revision. Okay. Mungkin raya itu dah terlupa kan, nak baca lah sikit-sikit. 10 soalan ni. Saya sampai tajuk terakhir yang kita belajar. I think about join, is it? Yang terakhir sekali. Join and bone. Kalau saya tak tersilap. Is it? Betul tak? Betul?
Betul.
Jadi kita ada 4 ke 5 topik, ada 10 soalan. So, satu topik lebih kurang 1 ke 2 soalan sahaja. Basis concept of everything. So, have a look and you may start taking your quiz by 12 o'clock. So, I open it up until 1 for your class to finish it up. Thank you again for your participation. Don't forget to take your attendance. With that, Assalamualaikum and see you again next week.